Hey everyone, welcome back to the channel. Sorry for the delay since the previous video. I spent most of the time either benchmarking or writing code to put the results into charts, but today we're going to go over some benchmarks for games running on the Steam Deck. The games I've chosen to be the first are 5 current or last generation AAA games that'll show off what the deck can really do. But first, let's get some housekeeping done. As this is my first video showing off benchmarks, I'll be doing my best to show off things that matter in a coherent order, but please let me know if you have any feedback. I would love to hear it, trust me. Secondly, I'm a technical guy, and I'll try to make my insights a little more technical than the typical reviewer as a result. Expect some thoughts on thermals, clock speeds, and other non-frames per second stuff. I'll show the same metrics for each game unless something stands out in the results. The typical order will be a per setting FPS comparison, then we'll look at some metrics based on the game and how interesting they are. After that, I'll give my thoughts on what the bottleneck likely is and show some supporting data, and then I'll finish up with what I think the sweet spot is for gameplay. Lastly, my test setup was done with a Steam Deck 512GB model plugged in with no external display. I also ran the tests in desktop mode, but with game mode to get the results as close as possible to SteamOS mode results. I confirmed that both played the same and had similar FPS averages, so I'm confident the results will be within margin of error. Without further ado, let's get to some benchmarks. I'll lead with one of the hardest games to run today, Elden Ring. Even with my gaming PC with a 3080 Ti, it can struggle at points with this game, although that's at a 4K resolution. I'm not very far in the game yet, so this was taken during a 90-second walk around Limgrave at the beginning of the game. High settings were slightly lower, with the main difference being the 0.1% and 1% lows. This meant that the gameplay hitched at times, particularly when there was a lot of foliage on the screen. I would rate this as playable, but not pleasant. Extreme settings rarely reached 30 FPS, and it was unpleasant to play when there was anything of value on screen. It also experienced hitching issues, but they were far worse. Here, you can see exactly what the games felt like to play. In general, low and medium were very pleasant and stayed in the mid-30s, whereas high and extreme were not fun at all. The hitching in extreme nearly got me killed by a rider. Don't ruin a beautiful game by playing on this mode. Last up for the playability block is the frame time. This is in microseconds, so keep that in mind when looking at the numbers on the left. For 60 FPS gameplay, perfect frame time would be 16,667 microseconds, and for 30 FPS gameplay, you would have a frame time of 33,340 microseconds. As you can see here, only low and medium are under that threshold and remain relatively consistent, showing us that the performance and fidelity sweet spot is definitely going to be the medium preset here. Now, moving on to tracing the bottleneck, we find our culprit immediately. The GPU is topped out on the extreme preset. Something interesting here is that dip at the beginning of the low presets run. Upon watching the playback, I found it correlates with a large amount of foliage, so I believe that foliage density is to blame for the others not having similar behavior. Something else interesting is that all non-extreme presets settled in the 85 to 90% utilization range, which you wouldn't expect to see from the frame pacing results earlier. Let's look into why that might be. Again, this was pretty easy to find. The deck is doing a phenomenal job at using exactly the resources it needs to get the job done, even with something that should be far above its weight class. There's not much to say here other than it seems the deck really likes staying at around 90% utilization by default. In a later video I may explore raising the clock speeds, but keeping settings low to see how many frames I can squeeze out of it. The last thing of note for Elden Ring is that because of the difference in clock speeds, the low preset absolutely sips power at just 2 to 3 watts. That's insane for a game like this with higher end desktop GPUs pulling over 100 times that routinely. It's just a hunch that I'll have to confirm in my battery testing, but I'd be willing to bet that I could probably pull more than 3 hours of battery on Elden Ring with a little tuning. Make sure to subscribe to see that. As for where I think the sweet spot is here, I think the medium preset with a 30 FPS limit will get the best looking game and give the GPU a little bit of breathing room as well. Although you could definitely go down to low if you'd rather squeeze some more battery life out of the deck. I'll probably be sticking with the medium preset personally. Alright, on to the next game. Another game that's notoriously hard to run is Cyberpunk 2077. Here we can see that even at low settings we can't get a consistent 30 FPS. We can get a playable frame rate on low, but the key is that we're not using any form of FSR, AMD's upscaling technology. Something I noticed here is that Ultra tends to get slightly higher frame rates than High, although it had more jarring stutters that this chart doesn't represent that well. We'll get to FSR results in a second, but I want to show exactly how badly this game stresses the deck. With the exception of the low preset and a small dip in utilization when there was little on screen, the GPU is maxed out during the entire benchmark. Based on this graph alone, we can see that the GPU is definitely the bottleneck for Cyberpunk, so let's try to give it a little breathing room with FSR. Here we can see that FSR is enabled and helping immensely. For these tests, I used the default FSR for each preset. Low, medium, and high were set to automatic, while the Ultra and Steam Deck presets used the highest quality by default. From a playability perspective, I'd say that, unsurprisingly, the Steam Deck preset was by far the smoothest. The lows all happen during scene transitions and seem unavoidable, but the average frame rate was smoother than Ultra, and I could make out distant NPCs and details better than the other three presets. When it comes to how much headroom we gave the GPU using FSR, it wasn't much. That said, unlike the non-FSR results, we can get a smooth experience with a few more percentage points to spare. In particular, I noticed that the fan noise decreased by what I guess was a few decibels while using FSR. On to what I'd consider a great showcase of AMD's FSR technology, we can see that even Ultra with FSR runs better than low without FSR, despite looking a decent amount better on the small screen. In a future video, I might do a comparison between non-FSR and FSR image quality, but that's beyond the scope of this video. Overall, I'd consider Steam Deck's FSR preset to be the king of fidelity and performance. I set my screen refresh rate to 40 Hz while playing after the test, and it was a great experience. But if you're willing to go down to 30 Hz, you'd easily be able to do a native resolution medium or FSR on Ultra. Let's move on to something with some odd results. Red Dead Redemption 2 is a classic example of a game that has a love-hate relationship with Linux. In theory, it should work flawlessly since it has a Vulkan rendering pipeline and tons of settings to tune, but in reality it has a bad launcher with a glitchy overlay, performance inconsistencies, and the new implementation of FSR has some interesting side effects. Here we can see that both of the FSR presets have astronomically high 97th percentile performance, with much more reasonable averages. We can see that every non-FSR preset is able to pull a minimum of 40 FPS average, while the FSR presets are able to get more than 70. Looking at the GPU core clock, we can see something different from the past few games. FSR is actually using more of the GPU than the non-FSR presets. Seeing this means that the bottleneck for performance isn't the GPU, at least not for most scenarios. Let's check out the CPU. Yup, there it is. Non-FSR presets are absolutely slaughtering the CPU. What's interesting is that in most games we'd expect this to be the opposite. FSR should be giving our GPU a little break and the CPU should need to run harder to keep up with the higher frame rate. But Red Dead's engine is clearly relying very heavily on the processor for rendering for some reason. Something you may notice is that some presets are missing from this chart. Ultra without FSR, High with FSR, and Ultra with FSR all crashed repeatedly during my testing. Ultra without FSR actually caused my Steam Deck to hard reboot each time it was run, which I suspected was because of a bad memory leak. Looking at this chart, you can see that I'm almost certainly right. It seems that memory usage will continue to increase indefinitely, but I needed the test to confirm. I got into story mode and walked around for about 15 or 20 minutes in camp, and the game locked up once again. Looking at ProtonDB, others have a similar issue, so hopefully Rockstar fixes it soon. Aside from the crashes, however, the entire game was beautiful, and playing at a locked 60 with FSR set to maximum quality was exactly how I see myself finally completing Red Dead 2. Next is Horizon Zero Dawn, as usual starting with non-FSR results to see what would be the most playable at a native resolution. We can see that the original PS4 quality averages over 40 FPS, which is 33% faster than the actual PS4 could play it, so it's a very pleasant experience. Locking the refresh rate at 40 makes this feel like a genuine upgrade from either the PS4 or PS4 Pro, but it doesn't play quite as well as the PS5 enhanced version, nor would I expect it to. Looking at the GPU core clock, we can see that the GPU is the bottleneck once again, with only low and original settings giving it any real breathing room. Because of this, we can hope that FSR will give us some good results. Just as we hoped, FSR gives us an average FPS boost of 17%, with low being the smallest change at 8%, and ultimate being the largest with a 26% difference over non-FSR gameplay. On that note, even Ultimate is getting a fairly consistent 40 FPS, but the difference in FSR fidelity is especially noticeable in this game with all the intricate foliage. If you can handle a little bit of the screen door effect, it's typically fine, but if you'd rather avoid it, then I'd go with a non-FSR option. Combining the non-FSR and FSR charts, we can see that the curve flattens out a bit. All of these settings are more than playable, especially when locking the refresh rate to 40. The sweet spot here really depends on how sensitive you are to the screen door effect on small details, how good your eyesight is, or how picky you are. If you prefer a lot of fancy lighting and effects, then Ultimate with FSR is the way to go. If you'd rather have a smoother version of the way the game was originally meant to be played, then play Original with no FSR and lock your refresh rate at 40 Hz for a smoother than vanilla experience. On to the last game in this part of the review, we have Dying Light. This game is a little older now, coming out in 2015, but I think that it's a good example of a first-person shooter with a more traditional engine. As we can see, there's very little different between the presets here in terms of FPS, aside from the lows. This game predates FSR by a decent amount, so what we see here is what we get in terms of presets. Where this game really shines is its ability to sip on power in the low preset. Despite looking very good for its age, it gets by on just 2 to 3 watts in the middle of the city of a post-game save file, all while staying at a rock-solid 60 FPS with VSync on. This is another game that I think is likely to last several hours on battery with a little bit of tuning. Since we know that the GPU isn't our bottleneck, I decided to check out the CPU and found that it had a lot of breathing room as well. I actually think that we could get away with either core or voltage binning here, further lowering power consumption. I'll be sure to try Dying Light out during my battery test to see how long we can prolong the battery on a last-gen AAA game. The sweet spot here is definitely an in-between. I chose the performance preset, then enabled VSync and FXAA. The result was an extremely smooth 60 without much aliasing and basically zero input lag. Definitely a joy to play with those settings. And there you have it, 5 big semi-recent games that are all a delight to play on the deck. With the exception of Red Dead 2, I didn't have any issues booting up or playing the games, and Cyberpunk 2077 even had a great out-of-the-box preset. The Steam Deck really excels at being pick up and play in a way no PC I've had before has done, with performance I didn't really think was possible. I'm typically extremely picky with my graphics settings, fan noise, builds, and a million other things, but the deck really delivers. Next time, we'll be going over another handful of games from either a different era or genre, so please make sure to subscribe and leave me a comment with any feedback on this video so I can implement it in those videos. See you then! I just want to say thank you for everybody who's subscribed and watched my previous video. I didn't expect it to take off nearly as well as it did, and it's been a joy seeing it climb up in views. The past week I've been writing code to create the graphs you've seen in this video. So please, if you appreciate the work, make sure to like, comment, subscribe, do whatever those call to action things are. I'll be releasing many more of these videos with different benchmarks for any games that I have or I can get without breaking the bank. And if anyone's interested, please let me know and I can open source the code that I made for parsing these Mango HUD logs. See you next time.